this is Shinchan. So, in the today's tutorial, we will be actually having a look at the support vector machines and the ensemble classifiers, means ensemble models, right? Firstly, let's actually discuss a bit about the support vector machines, that what are they and what is the aim of today's practical, right? So let me actually recheck that if the recording is on. Yes, nice, recording is on. Now, we will be actually provided a file in which we are given the whole run of a support vector machine, which is actually run on the blob. We have to do what is, we have to change it to our data set, and the data is about apple and oranges. So what the dataset actually looks like, the dataset actually looks like in such a way that you have two columns, that is actually weight and size, and you will predict accordingly that whether it is an apple or an orange, right? So this is your main problem, and the model you have to use is actually support vector classifier, right? Based on support vector machines. So what support vector machine actually does, it actually finds two such points or some more such points which are actually correctly able to predict the particular line, which can further classify the testing dataset, right? Means for this particular dataset, you can actually have a look that you can create a line here, and then based on that particular line you can further predict the testing records which you will be providing it for the testing data. So yeah, getting started with mounting my drive, you already know that this is how I actually used to mount my drive, and why I did mounted my drive is because I actually used that particular CSV file from my drive. You can also upload it here by using that particular button. Just a second, it is actually still connecting. Okay, so you can actually use this particular button, and then you can upload that particular CSV file here, and then you can just right click and copy path, and then you can just read CSV by using this function. So yeah, that's why I'm actually mounting my drive, because that CSV file is actually in my drive. Next, we are actually importing some libraries which we will be actually using around to plot the graphs. So firstly, we are actually using NumPy, because we are actually handling something somewhere with the NumPy arrays and the arrays. And then we are importing the matplotlib.pyplot as PLD to actually plot the figures, and then we have the SkyPy as star import stars, and Seaborn I don't think we actually use it. Okay, then we can also remove this particular statement, because we are no longer working with blobs, we are actually working with real data set. And then I will actually import the pandas as PD, because I have to actually import my because I have to actually read my data set from this particular file. Then I'm actually printing the I was actually printing the head, means first 5 records, by using the df.head, and then df.describe to actually get the minimum and the maximum value, because I will be actually needing that for plotting the graphs. And then what I was doing is that I was actually getting the values of those features into x variable, and this is how I actually used to get that df and then square brackets. In that you will supply the name of those columns which you want to take in the features, and then in the y variable you will actually get that class variable, because the class is what is actually getting or say taking the class outcomes, means something like the orange and apples and whatever, what is the actual name of that particular record. So I was actually printing the first 5 records, not necessary, you can just do it for debugging that whether you have correctly got the x and y variables or not. Then what I'm doing is that for plotting those particular values, I will also need to supply the value of the colors, right? While actually I use scatter, so I actually need to supply the value of colors, and the way I actually used to supply that is by providing an array of zeros and ones, 0 for the apple class and 1 for the orange class, and without using any categorical and encoder or any other library which I might have mentioned in the previous tutorials. I will just use a for loop, simple for loop, just for the sake of easiness, and I will just check if it is an apple, then I will just append in the color list a 0, otherwise I will append a 1. Simple as that. So what I'm doing in actually is that firstly I'm actually catching the values, because it is actually a data frame. When I actually used to get those in such a way, I used to get a data frame, and then getting the array representation of the same, I will use the values thingy for that particular data frame, and then I will get the array accordingly. Then I will do that for y also, and get the array representation in y, and then I will just do just run this particular for loop, and for the apple I will just push a 0 in this particular list, and then for an orange I'm actually pushing 1. And then now it's the time for plotting this graph. So I will use a plt.scatter function. Plt is actually matplotlib.pyplot as plt, which was actually imported earlier. So I will actually use its scatter function to plot a scatter plot, right? Now, how a scatter plot looks like is something like this, which actually includes your points and which are actually distributed over your space according to the x and y values. So for the x value, I'm actually giving the first column. That was actually for the x-axis, I'm giving the weight as the first column, which is will be actually used at the x value of this particular graph, because it's a 2D graph. And then for the y value, I'm actually giving the size as the column. So this is how I actually used to do that. I might have either used the XARR, because this plot function takes an array instead of the data frame. So that's why I need to use the x dot values instead of x directly, because x is the data frame and it will give an error. Now, similarly for the y values, I will give the first column, and this is how you actually select. The column here actually means that you are selecting in the ND array. You used to select all the rows by using a column, which will actually tell you that you are actually selecting all the rows. And then 0 means you are only selecting the 0th column. If you have to select somewhere in the future some of the columns, like say from 0 to say yeah, from 0 to something, say 1, then you will supply something like this. But yes, for that's for the future use. Here only we need only is the 0th column, that is one column only. And then for the y1, you are actually supplying the first column, that is the 1 index column. And then in the color list, the c is the actual variable which actually takes the array of the colors which are to be printed for those points. Because if you will not supply this particular point, let me actually show you what will happen. If I will not supply this particular one, I need to run everything. Just a second. Okay, so this is actually requiring some permission. Okay. So yeah, after that I will be mounted, my these libraries will be imported, and then yeah, I'm actually running this particular function. And then let's actually have a look. That here you are actually able to see that it will just color everything with just a single color, because you have not supplied the C parameter. And if I actually again take back those 0 and 1 array which I created with this for loop, I will be actually able to get those two colors, right? And the C map is just I think a theme for the color, that is actually autumn, 0, yellow and red. And then what I need to do now, actually you are able to look that the ranges are actually different. You are actually able to get the minimum of 65 for the weight, and the maximum of 75 for the weight, and the minimum of say 4 for the size, and the maximum of 5.8 for the size. So the ranges are different, and that's actually pretty bad if you are actually trying to get a good accuracy. So you will do what is actually scale down all the values to the same ranges. So how you will do that? You will use the standard scaler. You might have also did it manually by running a for loop, getting so what's the formula of say min max normalization? You actually take the particular value of that particular cell, and then you actually subtract from it the min, and then divide by max minus min. So that's how you will do it, and you will get the min from here, max from here, and yeah, this is how you will standardize by running a for loop. But for the sake of easiness, I'm using a standard scaler. Otherwise that stuff is also easy, not very well. Now, so how you scale using the standard scaler is that you will just use the scalar from the scalar preprocessing module. You will just import the standard scaler, and you will just instantiate an object of the standard scaler into sc, and then with that sc.fit transform function, you will just apply x as the value. Now, what was x with you? X was actually the data frame which was actually containing these two columns, weight and the size. So you are actually supplying that here, and then you are actually in turn getting an array as a return value from here, which is of the scale value. You can actually have a look that you are actually getting the scale values. Let me also run this particular column. No issues, it will give the same output again. And then I now what's the next step? Next step is actually to try out different lines which might actually separate these particular two classes. So this is just a manual work. I just tried the different lines. Means how I actually plotted different lines is that firstly, this is actually just creating an array, means creating returning me an array which is actually containing all the points from minus 2.0 to 2.0, so that I can actually get the y values according to these values and can print my line. This is the base logic. So yeah, these are the okay. Then we are actually just plotting simply those particular scaled values in the scatter function like we did earlier, right? Earlier we were actually just plotting the bare values, but now I'm actually plotting the scale values, and they are in turn having the similar distribution. Now then we are actually plotting this particular red marker on the 0.5 zero point 0.5, which actually denotes that it is a particular line which we are actually going to choose because it seems the best one, because it is actually having the most margin from all of the points, that is from the two classes. That's actually the base logic of support vector machine. And then here is the marker size equal to 2. You are just changing the marker size and marker width, etc., which are just for the verification purposes. Now this is the actual for loop, which is actually printing you three lines. Now how this is actually working: this is actually the slope, and this is actually the intercept, that is the y-intercept. If you remember the equation of line, that is actually y is equal to mx plus c. Wait a second, what is that? Yeah, y is equal to mx plus c. So what happens is that you just need the m and c values, and then you can actually get put the x values, different x values, and you will get the different y values. And the same logic is actually implemented here. You're actually supplying the m and the c values, and then you will do what is actually with for that particular x value. You are actually calculating the y value, m into x fit plus b, and m is actually caught from the first one of this particular set, and then we actually get a tuple, and then from the second element of this tuple I'm actually getting the intercept. And they are coming one after another with this for loop, and then I'm actually getting those x and y values for these lines which I'm actually printing up. And then in this way I'm actually able to print those lines. Then I'm actually limiting my stuff, means my graph, from otherwise it actually exceeds a bit. So I'm actually limiting it to -2 and 2, because yes, it is the particular range which I think is sufficient for me, because my scale values must be actually going, if I actually have a look, then my scale values will actually go between this particular range, so I don't need any graph further than it. So now next step was actually of this particular stuff, that where we are actually trying to also put the margins around these line, because in the support vector machine we have learned that yeah, we actually have a look that we used to have a margin around our lines, and we used to see that how many points are actually coming in between those margin and how many are not. So whichever lines is actually just avoiding most of the points to actually come inside the margin, that one is actually the best line, or say best classifier line, which will be actually used for the later predictions. So here also you are actually performing the same logic. The difference is that you are actually also using this particular line, which is actually just printing this grayish portion, which is actually plt dot fill between x fit and then y fit minus d and the y fit plus d, so that we can actually print d distance below and d distance upwards also. And then yeah, and then you are actually doing it once again. Mm-mm. Yeah, now you are actually just using the edge color because you don't want that edge color, and then you are supplying us a bit of alpha value, so that they will overlap a bit, and you will be actually able to have a grayish type portion. And the AAA is actually the code of a gray, I believe, because yes, it is how if you actually supply all the letters to be same for the hexadecimal color, then it will actually come out to be a shade of gray, and this is how you actually supply gray color. And you are also supplying opacity value to be 0.4, not 1, so that all will be actually visible while even overlapping. So yeah, here till yet we are actually just plotting the graphs, and did nothing with the support vector classifier or say anything else. Now it's the time to actually implement the support vector classifier. So how we used to do that is actually from the sklearns svm module we will import the svc, and then we will just instantiate our model, that is our main model will be instantiated there. And then this is how we will do it, that model is equal to svc kernel is equal to linear, and then c with the value of something, right? So what we are actually doing here, we are actually supplying a function, that is a kernel function, that which function we are actually going to use, and we are also supplying a value of c, right? So yeah, c is actually our value here, which is actually kind of a hyperparameter, if you wanna consider, or if you wanna learn that it's actually a kind of a regularization parameter that actually tells you that how much you must not overfit. That is, it is a kind of a variable that is actually used to avoid overfitting. So yes, because this classifier can be overfitted, so yes, to avoid that we actually use a hyperparameter regularization parameter, which is with its particular different values, it will affect the classifier accordingly, and it will in turn accordingly take different points of consideration to create its line. Yeah, this is the basic intuition. So yeah, you are instantiating the svc into the model, and then I'm actually reshaping the y array by using the y array dot reshape, because it actually takes the reshaped value, otherwise errors used to come. So yeah, by from that particular array I'm actually reshaping it to my array, and then I'm actually just fitting my model with the x scale and the y reshaped. And then I have actually fitted my model means training is complete. Yes, support vector classifier actually trains very quickly, because it has to consider only a few things, and then it is actually directly able to calculate the particular slope of that particular line which it is actually going to implement. Now this is a particular function which actually in turn just prints a particular graph, right? So we are actually just creating a function which is actually taking the model for which you have to print the graph, that is you have to print the line, and it is also taking the axis, means the hold of that particular graph on which you are going to print that particular graph, and there are another parameters which you are actually supplying. Then we are actually then we are actually plotting our graph, right? Firstly we are actually plotting the simple points like we did earlier also. So this line will actually just print your points on the graph, that is the red and the yellow points, and then same color lace is actually supplied with the marker size of say 50, and the c map color map is equal to autumn. Now you are actually calling the function which you have defined here, and then here you will actually pass your model, right? And nothing else is passed. They will actually be handled with the default parameters. And you are just applying the model, and in this from this model you are actually somehow getting the support vectors, that is those particular points which are actually defining your results. And then yeah, you will actually print a line over them, right? Something like this, a dotted one, which actually used to tell the margin, above margin and below margin of your particular line, and this is your main line which will actually classify the further points. Now we can also gather, if you will notice precisely, then these lines are actually passing through these two red points and this yellow points, and you can accordingly get the locations of these particular points by using the model.support vectors, support underscore vectors underscore, and in there here you will actually get the x and y values of those particular points, right? And if you will notice that then these are actually these particular points in which the line is actually passing. So 0.2 and 0.5, where it is, let's actually have a look. That 0.2 will be something like here, and 0.57 will be say something like here. Yeah, so it is actually defining this particular point, and similarly these and this point are also defined here as the support vectors, as the points which are actually defining your line. Now this is another function which on the base of the n value will actually plot your graph. That is you are actually trying to now have a look that trying to research that how the number of points, or say how the number of records actually define your lines, and the results are actually a bit say in the intuition towards the thing that your line is actually deflected bit lesser with the number of points, and you actually used to get the same classification line, or the same sloped line, means similar slope line, not exactly same, with the number of points increasing. So yeah, it's actually a function which actually takes into argument as n, which is actually the number of records which you are actually trying, and accordingly by default it is actually supplying n is equal to 10, so that it actually gets the first 10 records from the x and first y records from the first 10 records from the y. And similarly I will be needing the first 10 color values, that is 0 or 1. Actually here the color value is kind of encoding. You might have used the categorical encoder for that. That is apple will be encoded to say 0, and the orange might have been encoded to say 1, and that's all. Nothing else so much complicated. And then we are actually just running we are actually fitting now a model with those particular records, that is the first 10 records from x and y. And then from that particular model I'm actually just again calling my that particular function which actually plots my decision boundary, that is actually from my classifier line which you have got from the model. I'm actually calling here, and then I'm actually plotting my simply my points which I have actually taken into consideration for training for this graph. And then yes, here just I'm actually putting the title and all, nothing else, so much nothing else so much fancy. Yeah, so I'm actually calling this particular plot svm function in a for loop because I'm actually just doing it for second in 40. This is actually a range which is actually doing this for two stuffs, that is actually for the 10 and 40. That's why it's actually plotting two graphs. So you can actually have a look that for the 10 points, it is actually plotting this particular line, and for the 40 points, it's actually plotting this particular line. Now, I can also use something interactive widget from the IPY widgets. I can actually import the interact, and the interact is something like that. Is actually it actually gives you a drop down menu on which you can actually supply the particular values which you might be wanting to say plot the graph for. So I'm actually supplying the values of the 10, 15, 30, and 40, and as I've actually made a function to actually plot or say fit the model for that particular number of records. So what I will do is actually when the value of a particular when a particular value will be actually clicked, like say 10 is selected or say 15 is selected, when this drop down will open, then what it will do is actually it will just supply here that particular n value, and then this particular thing will actually, this particular function will actually print that according graph here. Now for now it is actually printing a graph of 4, and I need to actually run this particular block to actually execute this particular interactive block, otherwise it will not run. For now I'm actually just explaining this as. So yes, till now we are actually able to train our model, that is support vector machine or say support vector classifier, for say variable number of points, and that was that what we have done with the help of say various function. And so what's our next step? So yes, we have to do is actually we have to try out different kernel functions. So yes, I actually that's a bit. So kernel function is something like a type of a function which you want to actually fit in this particular model. For straightly saying, you can actually fit a simple linear function around that. If the data has been around circular fashion, then you might have used something like a called a RBF. There is no sense to actually use a linear function there in that particular case, because yes, you can't just fit or you can't just separate the circular data with a single line. Yes, so yes, you can't use the linear there, but yes, here you can use anything because yeah, it is actually a simple data set only of 40 records, and the things are actually separated, can be separated with a single line, so you can use linear. But yes, we are actually trying out different kernel functions here like this. What you have to do is actually simply you have to just apply here in the kernel the value of that kernel function. There are various values of say kernel function like linear, poly, RBF, and sigmoid, which you can supply here. You just need to simply I also need to no don't need to actually import it again because it is already imported. So yeah, you can again create the support vector classifier with the instantiation of say SVC, and then you can just again reshape that y array and then pass it, that is a fit, and that particular model with the x and the y values. You can again use that plot SVC decision function to actually plot these boundaries which you actually cut from that particular model, and then you can supply your RBF model there. Then you can do this for same process for the poly, just a variable change, and then you can just apply in the kernel parameter, that is the poly value, and then similarly you can do it for sigmoid. And yeah, that's actually the basic stuff. You can actually have a look at the different say shapes, say different boundaries which you are actually getting. In the linear one, you are actually getting a same simple straight boundary, and in the say RBF one, you are actually getting a curve boundary, because yeah, it's actually not a linear function. Then you in the poly you are actually getting a polynomial line, and then for the sigmoid you are actually getting a straight results. I am actually not obvious that why it is actually coming. Now we have to actually work on the grayscale CV. So yeah, we have done it for the different values. So one question must arise in your mind, that which one to choose. Yes, this question actually arises, and that's why we have the solution. We have the solution for the same is that to use the grayscale CV. And like what this does is actually it handles pretty hard stuff of actually choosing the best one for you, and actually supplies the best arguments for you. So what you need to do, you might have actually noticed that there was an argument of CC which I was talking to be the regularized parameter. So must be the value of that particular regularized parameter? So yes, here we are doing that. We have a module in say sklearn.model selection, and that is actually grid search CV, and which actually does this hard work for us. So what you need to do is that in the param grid, that is actually just a defined variable, you are actually just applying with the C with the list of those values which you think that might be useful, and this particular function will actually does all the work for you, that is of choosing the best out of this. And then for the gamma also, you are actually, this is another parameter which you can actually use in your SVC, and then you are actually supplying these are values, it will choose the best out of them. And the values are actually in decreasing order from 1 say to say 0.1 and so on, and the C values are actually in the increasing order from say I've started from 10, you might start from any value. value, and then non-negative. Now we have actually say grid. We have actually instantiated our grid search CV, and inside it I'm actually just passing an instantiation of say SVC, an empty instantiation, because it is actually not actually supplying an initial parameter. The function will actually supply the parameter by choosing from this, and this is actually starting with the braces, if you actually notice. Then we have to, for the second parameter, we're actually supplying the param grid, and then we have another parameters like say verbose is equal to 3 to actually just print out all the values whatever is actually doing. And then we have the say yeah then we are actually like what how we used to train the models. We use to fit these like a grid dot fit, and then you actually supply the XXC and the YD shaped, because yeah, it is the base data set which you were actually working on. So you are actually supplying the same thing, but yes, you are actually calling a fit function. It will inside it call the SVC many times, really many times, with the different combination of these parameters. So yes, in the end, when this all training is actually completed, you can actually get the best params by using the grid.best params and the grid.best estimator, right? The grid.best params will actually give you the best parameter value, and the best estimator will actually give you the instantiation of that particular model, which is the best one, which is actually found with the best one with these parameter values, right? And then what I'm doing is that's the extra stuff that's actually just making the best model. That is what the parameter I've actually got. I'm just training a model with that by just splitting my X-train manually, not with that train test split. I'm just manually getting the first study and as the last 10 records, and then I'm actually just fitting the X and Y, X train and Y train, and then testing with my values, and in a for loop I'm actually getting the correct. So yeah, oh, wow, it is actually getting 10 out of 10 correct. So my model is actually pretty awesome. So yeah, that was a basic intuition behind the support vector classifier, and thank you for watching.